name is Lena Aziz. I'm Habitat Programs Director at Watershed Watch Salmon Society. So Colony Farm is an incredibly accessible farm where you can come out and actually walk the trails, which are also the dikes. So you can see very clearly flood infrastructure in action. You can see the floodgates, you can see the pump station, you can see how the Coquitlam rises and falls because it is impacted by the tides. Especially in the freshet when you've got a high Fraser River and then that backs up into the Coquitlam, like you can see all of that in action. So what we are looking at is how can we use technology in a way that benefits us the most and benefits salmon the most as well. And the study here at Colony Farm is looking at one particular type of floodgate, a fish-friendly gate that works on a hydraulic arm, to see how fish-friendly it really is, and then we can start to recommend that as one of those good solutions for other local governments, other owners of flood infrastructure to adopt more as they are preparing their communities or their specific areas for flooding.
My name is Zachary Shirker. I'm a PhD candidate in the Pacific Salmon Ecology and Conservation Lab at the University of British Columbia. And my research focuses on small-scale barrier remediation and restoration. And I like to look at basically how effective are different remediation approaches so that we can maximize the benefit to the fish that we're trying to work with. And this area in particular is actually the floodplain. So we're currently standing on a dike which has basically worked to limit the extent of the floodplain in this area, but everywhere around us 100 years ago before this dike was put in would have been underwater at different times of the year, and as a result providing habitat for all sorts of aquatic species, but juvenile salmon in particular. Unfortunately, water builds up behind these dikes, and that water has to be basically drained back into the river, and our workaround for that are these things called floodgates. And floodgates are basically a culvert in the dike, so basically a big tunnel that's in the dike, and it's designed to transfer water out of the floodplain into the river while limiting the river from coming into the floodplain and flooding things again. We are at the point where we have to replace some of these old floodgates and some of these old dikes. We have to build things higher. They're not graded for the situations that we currently are under, where it's a little bit less predictable with the flow and the timing of river movement. And so as a result, we have to fix these things. It's a perfect time to be replacing these structures with a fish-friendly alternative to reopen access to these habitats for juvenile salmon, especially since the structures that we replace them with, as we've learned, will be in place for the next century. Basically what we do is we use these things called PIT tags, passive integrated transponder. It's the same type of tag that you tag your dog or your cat with. It's the very same technology. We set up detectors on either end of the different floodgate structures that we're looking at, and from that we can actually see when fish are approaching these gates, at what time in the tidal cycle, what time in the day, and when they're successfully getting through them and what the gate is doing at that time. This kind of information is really important for understanding how we can design a floodgate or tweak a floodgate to more improve the access to these habitats and allow more fish into this area.
Fish-friendly floodgates tend to open more than a regular floodgate. So the old school top hinge mounted floodgate stays closed nearly all year round and really only opens if there's enough water behind the gate to push it open, so enough of a hydraulic force, and of course that has to be coupled with low enough water on in this case the riverside, the Coquitlam riverside, so that the gate would open and allow water to come out. Often when that happens, the velocity or the speed of the water is so high that little baby fish, little salmon, have a hard time trying to get into the channels behind these floodgates. So they don't work really well. They keep fish out. However, these newer fish-friendly floodgates tend to stay open much longer, anywhere from 60% longer to some gates open 90% longer, which is amazing for fish. And then you see them, especially the ones that are open 90% longer, they will close, especially if there's a threat of floods.
There is a massive disparity in how these floodgates are impacting juvenile salmon. So for example, there's a site that we had where we worked with the city of Coquitlam to chain it open during overwintering and basically return the land upstream to the floodplain. And at that site, we saw that over 80% of the fish that approached the structure successfully made it into that structure to survive through overwintering. And when they did, they spent on average about 75 days upstream of the structure using that habitat. That compares with a top-mounted floodgate, which is representative of almost all the floodgates on the Lower Fraser River, about 168 in total, blocking about 85% of the historical floodplain habitat. And these top-mounted gates are really not good for juvenile salmon, is what we found. We found that of fish that approach, less than 7% of fish get into those floodplain habitats. They stay for a shorter period of time because the water quality basically sours earlier than the other site. And then this self-regulating floodgate, which is one of two on the Lower Fraser River, it's a pretty forward-thinking technology as far as keeping the floodgate open on an incoming tide while allowing the gate to close when there's a flood risk. And what we saw is that at that site, we have about 50% of fish that approach the structure get in. That's the point of all our work. We want to be sure that people that are making the decisions on how these structures should be fixed have the appropriate information to design something that will really work for fish and work for the humans that live upstream. And I think that's sort of the intersection that we're at right now.